Dear students, today we will discuss the assembly language programming of 8051 microcontroller. Today program logic is related to the timers. Generate the square wave with t on of 3 milliseconds and t off of 10 milliseconds and all ports of port 0. Assume an crystal frequency of 22 MHz. Okay, in this first you can see the t on is 3 milliseconds. T on is 3 milliseconds and t off is 10 milliseconds. Right, that means t on, t off is 10 milliseconds. 3 milliseconds, this is 10 milliseconds. See, both on, off, both are not equal. That means both have a different delay. So it have a this milliseconds we need to generate the different count of pulses, and this delay need to generate with a different number of count pulses, right? So we need to do the individual calculation for on as well as for off. For on 3 milliseconds, off 10 milliseconds. Here you can see on all the pins of port 0. In port 0 we have 8 pins. The range is from 0 to 7. 0, 0.0, 0.1, 0.2, 0.3, 0.4, 0.5, 0.6 and 0.7. This all I have considered. Okay. Assume crystal oscillator frequency of 22 MHz. Okay, first what is the procedure? I need to find what is the machine cycle execution time for the each instruction for this corresponding frequency. Okay, so the procedure is first you need to divide by 12. You will get 1.83 megahertz. Then you need to take a inverse of that value. That is, you can find what is the time for the individual instruction, execution of the individual instruction. So for individual execution of instruction, you need 0.56 microsecond when you operate in 22 megahertz. Okay, I repeat again. First, the given frequency need to divide by 12. Remember, okay, you will get on frequency. I need to calculate for individual machine instruction, right? So that you need to divide with the frequency. You will get a individual time, right, for execution of each instruction. 546 microseconds. Similarly, for now, we will go for off time calculation. For off time calculation, you know it's a 10 milliseconds, right? So the the procedure, that is a delay, the 10 milliseconds divided by the machine cycle execution time, right? So 10 milliseconds divided by 0.46, you will get 18315 cycles. Okay, so you will get 18315 cycles. What is the maximum count of 16-bit counter? 65,536, right? Minus 18315. So you need 47,221. If you convert into hexadecimal, B875H. This is the value you want to load in the timer register. Okay, now you need to go for on time calculation. For on time calculation, what is the delay? 3 milliseconds divided by what is the execution time for the single instruction? 0.546 microseconds. So you'll get 5494 cycles. Now this is a maximum count, right? Minus 5494, you will get 60042. So what is the equivalent hexa value? EA8A. This you have to load in the timer register. Okay, this is the logic behind this given program. Okay, now we will go for writing the program. Very simple. First you remember the procedure. First you want to load the value in the T mode, right? So first you want to say which timer, which mode I want to work. This is the first instruction you will be writing. So this is in hexadecimal. If you write in the T mod in bitwise, 0 0 0 0 0 0 1, that means this is timer 0, this is timer 1. So I am going to work timer 0. Which mode you are going to work? Mode 1, because 0 1 specifies mode 1, right? So this program we written for timer 0 mode 1. This is the first instruction we have written. I hope you understand, right? The second instruction, I am loading the value. Okay, which value I am loading? You can see here 75. So what is the 75? 75 B8, that is off time calculation. First I am loading the register value of off time. Okay, so that means, so 75 is a you know that we have what, B875. Okay, this is loaded in TL0 and this is loaded in TH0. Okay, this is a value stored in your register. Okay, now these values are stored. This is a label for the looping. Okay, now what I am going to do, in the program it was given you are going to use port 0. Okay, now in the all the pins I need to keep a 0 to be a low state, right? Because you are taking the delay of low value, right? You are this delay, this delay, this is for low value. So first, so that means first I need to initiate the port P0 as a configure as a 00H. That means port 0 to a low state. Then a call, that is absolute call delay. While you call this subroutine program, it will go directly to this, right? So now you have loaded the value. So set btr. So once you set btr, that means your counter will your timer will start to count, right? So value is loaded, so you just loaded, it's not started to count, right? Once it is, if you set a bit, tr bit, what is a tr bit? That is a tcon register bit, right? So this is a bit will enable your timer to count, right? So once you set this timer 0, right? So that is tr0. So once you set that bit, what happened? It will start to count, right? It will go from b875 to ffff, right? So it will go. Okay, so you can see here, during this transaction, what is your flag? 0. So that's what I am checking here, right? So during this transition, what is the flag? 0, right? Jump if bit is not set, right? So it is not set, only 0 only, right? So that means it will be checked, you keep on checking during this transition. So for every b875 b876, for every count you will be getting one clock pulse. So this is giving this transition, right? So during this transition your flag will be 0, so it will be keep on monitoring. Once it reach fff, it is going to the overall condition, right? So this condition fail because this will change to tf1, right? Because it will roll over to 0000. During this transition your flag will change to tf0. So condition fail, and I will clear the all the control pins, right? That is a tr and tf I have to clear. So this will become 0, this will become 0, right? So whatever previous value, that will be clear. Now you have to return to the main program. Why? Because you have executed only for off time, right? So again it will come into the main program, it loading the value, right? So what is the value it is loading? 8a and ea, the values are loaded, right? It is loaded now, but it's not started to started the timer, right? So here very important, see now I'm setting all bits to 1, because why? Because I need to generate the logic of 1, right? So and what I am doing, I'm passing the value port p0 hash ffh. That means all the values in the p0 will be considered as a 1, that is a all bit to 1, right? So what is the delay? So how to do that is, while it will execute, while it will run this delay program. Okay, now by setting all bits to 1, you are setting all pins of port to higher state, the high state, very very important. Okay, so it will come to the next instruction, a call delay. So again it will go to this program. Okay, so Okay, so it will go again to this program. So already 3 milliseconds process is completed. Okay, now the value is loaded, right? So once you enable this bit, so it will start to count, so up to f, right, to f. So once it, until this, you know that the timer flag will be 0, right? So the condition will keep on checking again. You need to understand first this JNB, that is jump if bit is not set, correct now, because f is 0, so it is 0, that means it's not set. So condition true, so it should be check, keep on checking, right? So once it meet rollover condition ff, right, so immediately this flag will change to 1, right? Then the condition fail, then all the flags will be clear, then return to the main program, right? So short jump back, so back, go to again to this value. So you can see this is a way 3 milliseconds, 10 milliseconds, again 3 milliseconds, 10 milliseconds, 3 milliseconds, 10 milliseconds. So this is the way how program is executing. I hope you understanding. Thank you.